Welcome to Monday. It's the 24th day of July, 2023. Your Day Weather Podcast brought to you by Cowboy State Daily. Check them out at cowboystatedaily.com. Well, the weather is going to be about as it should be for the last week of July. Hot temperatures and monsoonal moisture. Those two things will combine like they usually do in late July and early August to produce some of the hottest weather of the summer season. If you look at climate data, mid-July through mid-August is the hottest time of the year in the western United States, and that's exactly what we're going to see. So very warm temperatures will be with us all week, but interdispersed in that will be the surges of monsoon moisture that will lead to what I call hit-and-miss thunderstorms. What do I mean by hit-and-miss thunderstorms? Well, one day you'll get hit by a thunderstorm. The next 3 days you'll see them around you, but you'll miss them. There's really nothing to organize these thunderstorms other than being around the periphery of the high pressure ridge. And so that's where the most action is going to be. But we do see these monsoonal moisture surges, and it does get a little deeper, as we'll show you here by the weekend. And I do think by late this week and this weekend, some of the western slope and mountains of Colorado will get in some of that deeper monsoon moisture to bring you some needed rainfall. But it's going to be high pressure driven heat with monsoonal moisture, the ring of fire going around it. Also, at the end of the video, there's been some new data released, some new papers about the impacts of the Tonga volcano eruption that happened January 15th, 2022. In earlier podcasts, we've talked about this, and I've gotten many questions about, well, how will this affect our weather? What's it going to do? Well, honestly, we don't know everything, and it's hard to, but there's some new compelling evidence to suggest that this volcanic eruption was much bigger and is currently impacting the weather and climate and will likely do so for a while. And at the end of the video, we'll talk about that. Some great shots from last Friday evening from Ken there in Franktown. We had some isolated thunderstorms that turned into supercells across parts of the High Plains region late Friday afternoon and evening that could be seen from many miles around, giving us great shots like this. And then Chris showing us this shot of this thunderstorm. This developed out in northeastern Colorado late Friday evening and continued into Friday night, putting on quite a show as another one of these isolated supercells that could be seen for miles around. Just a beautiful cloud as it built and grew and got very tall Friday evening and Friday night. And we'll occasionally see that with these monsoon-driven thunderstorms this week. The radar this morning really showing that arch of moisture, a large area of nocturnal thunderstorms there in eastern Nebraska and western Iowa this morning. And you can see how they're traveling right around the ridge that is parked right here. So basically, as the ridge wobbles, this axis will wobble as well, directing moisture east and west and a little north and south as that high wobbles. And you can really see it on the satellite imagery this morning. This is the water vapor photo. The gray areas show the deeper moisture. And you can see it going around the high, the center of the high down in New Mexico this morning. You can see a lot of dry air down here in the south. But we do have the higher moisture content air coming up out of Mexico and curving through. It doesn't mean if you're under the gray, it will rain on you. What it means is the atmosphere, if the conditions are right, could lead to an afternoon or evening thunderstorm, whether it's from daytime heating or the combination of daytime heating getting forced up the mountain slopes to help grow those showers and thunderstorms. And there's really, at least for several days here, nothing to change this current setup, nothing to sweep out the moisture. So it's going to be around, and some days there'll be more moisture than others. And again, this is really subtle, but notice there's a little bit of blue in some of these little patches. These are thunderstorms and showers, but they also are representing upper level weather disturbances that help enhance the chance for showers and thunderstorms. So the timing of these disturbances as they curve around really will indicate where the best chance of thunderstorms will be on any given day. And these will pop up, and they're hard to track sometimes. They tend to be small scale, but they really are important in terms of where those thunderstorms will be driven. So you can see that big high over northwest New Mexico this morning. That's going to build the heat dome and keep our temperatures very hot while the moisture circulates around the edge of the high. This is for Friday. So this is today. This is Friday. Notice the high pressure ridge gets flattened off a bit at the top. The top of the mountain get sliced off by Friday, but the main high is still staying down to the south here. Getting the top cut off will send some cooler air, slightly cooler air in from these areas here. So yes, it's going to be hot, but the extreme heat, the hottest of hot, will continue to be contained in the deserts. And over the next 7 days, it is going to be warmer than normal for just about all of the U.S. We'll get some of the heat into the east. It really, honestly, hasn't seen much of it this summer, but they'll start to see some of the heat. The hottest of hot will continue to be down into these areas here. Now, let's take a look at the precipitable water forecast starting today and going through the week and then ending by next Monday. So you can see, as we've shown you in these loops before, the white and the green areas show you where the deeper moisture is. The brown areas show you where the air becomes a little bit drier. So you kind of see some back and forth. And the last frame there shows you the deeper moisture by this weekend and into early next week. But there's a fair amount of green and white that's there off and on over the next several days, really over the next week. And that's going to feed the afternoon and evening thunderstorms. So where you see the brown, less storms and a drier pattern, where you see the green, the white, and the blue, that's where you're going to get the heavier rain-producing showers and thunderstorms. But it comes and goes. The frequency of thunderstorms will be really dictated by the intensity and the deepness of this precipitable water as you see it going on through. So this is a very typical pattern for this time of year with these plumes coming on through. That's why these thunderstorms are going to be hit and miss over the next 7 days. Now, if we take a look at the thunderstorm forecast, where the lightning is expected to occur, you can see that it basically is happening in the same areas, around the periphery of the ridge of high pressure. But if you look at northwest Mexico, through Arizona, through the Rockies, and then right on the adjacent plains, where the terrain helps to drive the development of the thunderstorms, because you notice that the Continental Divide is kind of the focal point to where these thunderstorms are going to want to be. But then also notice that they're really going to want to be here more often than not. But sometimes they get a little bit further north. Sometimes they'll arch a little bit further south. But these axes right here, as the high pressure wobbles, will dictate where they're going to be a little bit more numerous on any given day. And the high pressure ridge and the monsoonal moisture, the dominant players in the western U.S. weather here for the next 7 to 10 days. And if you look at the Storm Prediction Center, you can see that the more severe weather threat is going to be in the Midwest, but the green area here, those light green areas mean what we call general thunderstorms. This is for tomorrow, a little bit of a higher risk in the Dakotas for severe weather during the day on Tuesday, and then for Wednesday that shifts more southeast. But notice, there's that arch right there, and then less in the way of thunderstorms underneath the center of the high pressure ridge. Over the next 10 days, the water, the forecasted rain that's going to fall is showing up very well there. But look at the front range of Colorado and notice some of the western slope of Colorado, the front range, Arizona, the monsoon is deeper as well. But if you get west of the divide up here, yes, there's going to be showers and thunderstorms, but they're not going to be as numerous in western Wyoming, eastern Idaho, the Wasatch Front, western Montana. You're kind of on the edge of the action. But if the high wobbles a little more west, some of those deeper plumes of moisture could be a little bit more west as well. But everybody in the green, orange, yellow, blue colors here are going to be experiencing the occasional shower and thunderstorm pattern. As we go into the next discussion, so I remember showing this to you guys right after it happened. For those of you who've watched the podcast since January of 2022, this is the shot from space of the Tonga volcanic eruption. Now, what's important to point out about this eruption is that it was underwater. This was not a volcano that was above water like you would see maybe in Hawaii, but rather the volcanic eruption occurred well below the water level, the top of the water. So a tremendous amount of water, and this is really the key of this discussion, a tremendous amount of water was catapulted from the ocean surface to the stratosphere, not the troposphere. It went through the troposphere where we live and breathe. The stratosphere is the next layer of atmosphere above us. It starts approximately around 50,000 feet or so, but this volcanic eruption ejected its volcanic ash and especially the water into the lower levels of the stratosphere, higher than 60 to 70,000 feet. In fact, it could have even gone higher than that. In fact, it could have gone over 100,000 feet into the atmosphere. This is really important. Two things. It was an underwater volcano, so it ejected the water above it, a huge volume of water, and we'll tell you that in a moment. So since it was below the surface of the water, there was less in the way of ash, and also importantly, less in the way of sulfur dioxide, which you'll tend to get with some of the bigger volcanic eruptions on volcanic eruptions that are above ground level, like Mount Pinatubo in the Philippines, which threw a lot of SO2 into the atmosphere. So what does this mean? So where is Tonga? Okay, so just to review, it's in the southern hemisphere. Best to describe it, east of Australia, northeast of New Zealand. Basically, it's in the middle of nowhere. And it is in the southern hemisphere. And keep in mind, there is a little bit of separation in the atmosphere between the northern hemisphere and the southern hemisphere. But when you eject something into the stratosphere, it's going to spread out over time over the whole globe. And this is what's really important here. So when we looked at the first data that we provided about some of the initial estimates, the initial estimates were that 50 million metric tons of water got thrown into the stratosphere by this underwater volcano. Now, that in itself is a giant amount of water that goes into the stratosphere. And this is also something to point out. The stratosphere naturally has very little water in it. There are very few clouds in the stratosphere. Most of the time, the stratosphere is clear. There's just not a lot of water vapor in the stratosphere. However, this amount of water was put into the stratosphere by the volcano. Latest suggestions suggest it was off by a factor of 3. Now that is quite remarkable, a factor of 3. So instead of 50 million metric tons, the suggestion now is 150 million. Now this is coming from satellite data, taking a look at the information. As I told you before, when we've talked about volcanoes, volcanoes are different depending on if they're above water, below water. They're also dependent on when they explode latitude-wise. A high-latitude volcano will affect things different than a low-latitude volcano. It's not a simple answer with volcanic eruptions and weather and climate. And be very wary of anybody that tells you it's just one simple thing, just one thing that makes the weather and the climate. It's a combination of variables. Volcanoes is one of them, but it's not the only thing. But now 150 million waters is the projection. That's 40 trillion gallons of water. This is really important because when you put that much into the atmosphere, that's the most since the satellite era, meaning when we've had the tools to really measure these things. So in modern history, we haven't seen anything like this since we've been able to have the satellites and the ability to detect and measure these things. Now, Mount Pinatubo, as I mentioned earlier in the Philippines in the 90s, put a tremendous amount of sulfur dioxide into the stratosphere. Sulfur dioxide into the stratosphere is a cooling factor. However, water into the stratosphere is a warming factor. So you can actually have a volcano do two things: put in a lot of SO2 and make it cooler. You can put a lot of water vapor in the stratosphere and make the Earth warmer. Okay, but when we take a look at the chemical composition of the volcanic eruption, only 2% of the SO2 compared to Pinatubo happened with the Tonga eruption. So it was the water into the stratosphere, which is a warming factor, as compared to SO2. So very little SO2 has been measured going into the stratosphere from the Tonga volcanic eruption, but 150 million metric tons of water into the stratosphere. This is really important because the stratosphere water vapor increased by a whopping 13%. Now that may look like a low number, but when the stratosphere in itself is dry, by putting 13% more water vapor into there is going to change things. It's going to make an impact. What exactly are those impacts? Well, right now it looks like it's making things warmer since that January 2022 eruption of the Tonga volcano. And anything that goes into the stratosphere stays there for a long, long time because the stratosphere and the troposphere mix very, very little. So what gets put into the stratosphere stays for quite a while. So this is a huge, really important thing to point out. So this came from one of the papers that came out here over the last couple of weeks. So this is not my quote, but it's a quote from one of the papers. The unique nature and magnitude of the global stratospheric perturbation by this eruption ranks it as one of the most remarkable climatic events in modern observed eras. So this is big news. Of course, you got to go to podcasts like this one or go into the weeds to really find out more about this type of thing and how it's impacting us right now. So what is likely happening with the Tonga eruption is it's making the Earth warmer, not cooler, because of that huge amount of water vapor that went in there. As I get more information about the Tonga volcano, I'll pass it along. What does it mean in your neighborhood? I can't really tell you. It's complicated, but as we learn more and we study more, hopefully we'll find out what these volcanic eruptions will do to the weather where you live. Thanks for watching and listening. We'll see you tomorrow.